So here all that the solution of that questions which I have given you in like previous class in the PDF form. So I'm going to explain it how to solve this. Okay, so this is the first question was which was given in your PDF. The first question is that for the decomposition of dinitrogen pentoxide at 200 degrees Celsius, this reaction is given over here, and you can see that the initial pressure is given. Yes, so initial pressure is this much, 114 mm, and after 25 minutes of the reaction, the total pressure, this is total pressure, don't be confused, it is not the left pressure, it is the just total pressure, that means which is having reactant as well as product, and that is 133 millimeter. Okay, so you have to find the average rate of reaction in atm per minute. So it's very simple. I hope you people have done it. Yes, so let me explain this. Suppose that there is the decrease of P pressure. Okay, the P pressure is going to decrease in 25 minutes. So how we will write the equations? Like this is the equation, and initially suppose initially it is given 114 mm pressure. So let me write this, and at that moment the obviously the product pressure will be 0 because no pressure at that no product at that time. Yes, after 25 minutes, as I have assumed that P pressure is going to decrease. So initial was 114 and now P pressure decreased. So whatever the pressure of the reactant will decrease, the same with the same ratio, this product will form, isn't it? So for 1 mole, it is P pressure decreasing. So obviously for 1 mole, P pressure will increase. And here for half mole, half pressure will be increased, isn't it? Okay, so now the total pressure is this much. This complete is called total pressure. Yes. So, and this is equal to given 133 mm. So how to write? This is the initial pressure. This is the pressure of reactant, and then N2O4 and then O2 pressure. Yes, I have added all these three. So according to the question, it is 133. Now solve it, and when you will solve it, you will get this P is equal to 38 mm. That means in 25 minutes, that 38 mm pressure is going to be decreased. Yes, so we know decrease in pressure, that means if we have to find the rate of reaction, the rate of reaction is always change in, we have done in change in concentration upon time, but here it is, since we the gaseous atoms are there, so we will find change in pressure, okay, upon total time. So change in pressure is that 38 mm. Yes, 38 mm, but this is in mm, okay, and you are supposed to answer it in atm. So what we will do, we will convert this millimeter into atm by dividing 760. So 38 upon 760 we have done. That pressure, that is the decrease in the pressure in atm we got. Now for finding average rate of reaction, this is off actually. For average rate of reaction, we know the formula, change in pressure upon time. So 38 upon 760 divided by 25 minutes, you will get this 0.002 atm per minute. Got it? So this is the answer for the first question. I hope it is clear. So let's move to next question. Next question is that a rate of a gaseous reaction is halved when the volume of the vessel is doubled. If the volume of the vessel is doubled, what will be the order of reaction will happen? So it is quite clear. You can do the mental maths over here also, and you can find, but let me explain how to do this. Okay. Suppose the reaction is A change into product. So obviously we will write the rate law expression, R is equal to K A power 2N, whatever we can write, isn't it? That is like I had given the example. It is like this example. Okay. So the general form will be the rate is represented by small r and K, A concentration and the power N, which will give you the order of the reaction later on. Yes. So now the question is that the volume of the vessel is doubled. Yes. So if the volume of vessel is doubled, that means volume and concentration is inversely proportional, isn't it? So if the volume of vessel is doubled, obviously the concentration will be half. and the rate of reaction is depending upon the concentration. Higher the concentration, higher will be the rate of reaction. It is just directly proportional. So if the volume is doubled, concentration will be halved, and hence the rate of reaction will also be halved, isn't it? So can I write, instead of this r, can I write r by 2 k, and initial concentration a, instead of this a, I will write a by 2 power n. Yes. So just reverse it and we will get that 2, it is the constant r, and k constant, it is, let me move it. So if we reverse it, what we will get, this 2 is equal to the power n, and which will give you that if we know that if the base are same, then the power will also be same. So if nothing is given, so we can assume that it is n is equal to 1. That means it is the first order reaction. And here the mental maths also you can do. The volume of vessel is doubled, the rate of reaction is going to be half. That means volume of vessel is doubled, so concentration will be half. And concentration, if concentration is half, and here in the question it is also written that rate of reaction is also half, that means it is exactly directly proportional moving. Yes, isn't it? So that means the order of reaction is just 1. Then only if the rate of reaction is going to be, if the concentration of the reactant is going to be half, then the rate of reaction will also be half. Yes. Chale. So let's move to next question. This is the question of your NCRT. Yes, this is 4.20 and it was doubt for many. So let me explain this. First thing, you people haven't tried or may be confused by checking this name. Yes, then there is no role of this name, but still, since it is here, so let me explain the formula of this azoisopropane, what it will be. In organic, I have explained that azo means there will be n double bond n, isn't it? And we know that nitrogen forms 3 covalent bond along with a lone pair. So that means there is still one bond pair free free to form the bond with the nitrogen. Now leave it, this is the azo, okay, and here this is the isopropane. You can see isopropane, that means if it is attached to any group, it is attached with the second carbon, isopropane. So just propane is this 3 carbon. Let me attach the second carbon with the nitrogen, which will give you the isopropane. Yes, both side the same thing we will do. So here we got the azoisopropane. Any problem in this? Yes. So this is the formula, but you don't have to do any formula. You can write even azoisopropane change into hexane plus nitrogen. That also you can written in the word equation. In that form also you can write, there is no problem at all. Okay. Anyhow, this, when this is heated, you have done that whenever the azo compound is heated, it was liberating nitrogen gas, and whatever the rest jo bhi bach jayega, that will come together. So these three and these three will come together to form hexane, and N2 will come out. I hope it is clear. So let me do the question. So if it is azoisopropane is written like this. You can see this is the N double bond N, and the carbon is attached, and with the single carbon there was a 2CH3 group on both sides, isn't it, like this? Okay, it is going to heat it, and then it is giving N2 and C6H14, that is the hexane. Okay, suppose that initial pressure, it is P naught. Obviously at that time there is no product, so 0 0. After T time, uh, whatever the time it is, let it be T time, we have seen that we can observe that the P pressure of the P pressure of this azoisopropane is going to be decreased, and at the same time the product pressure will be increased. Got it? So if it is 1 mole, for 1 mole if it is decreasing by P, so obviously for 1 mole it will increase by P, 1 mole it will increase by P. Got it? Yes, any doubt in this? Now we have to do, if we will find the total pressure, the total pressure will be equal to initial pressure of the left pressure of the reactant plus both the product pressure, isn't it? We solved and we got this P naught plus P. So can we find this, the change in pressure? This is the change in pressure, P. Can it be will it be P is equal to PT minus P naught? Isn't it? This is, yes. So we got the change in pressure. The pressure which is decreasing here, that we got. Isn't it? So now, in that equation, the first law, integrated rate law, I have explained you the formula. In the formula, we have used the concentration because we have taken the for the solution only. Yes. Now here, since here it is gas, so instead of in concentration, what we will take? We will take pressure. Yes. So initial concentration was R naught. Now instead of this in concentration, we will take initial pressure, and which is P naught. R is was the left concentration, and instead of that left concentration, we will calculate the left pressure, and the left pressure is P naught minus P after T time. Yes. So this, now put the value of P in this equation. If I am putting this value from here, what I will get? I will get 2 P naught minus PT. Yes. Any problem in this? This is the left pressure. Okay, dear. Now first law, first integrated first law equation, red law equation. So what is this? This is the K is equal to 2.303 upon T log initial upon final. Yes. So in place of initial concentration, we will write initial pressure, and in place of left concentration, we will write the left pressure. Yes. So now there are the two time is given. So at every time we will find. Yes. So let's do for 360 seconds. That means 0 to 360, and first case, and second case 0 to 720. Got it? So we will check. So it is, if we see, this is 360 second. So 2.303 time is 360. Log initial was given here 0.35 and 2 into 35 because it is initial, and the PT. That means after 360, what is the pressure? This is 54, isn't it? So I have put that value. Now calculate it. Log 35 upon log 16. You take the value of log 35 minus log 16, then find the value of log 35 and then log 16, and you will get this value. Okay, after solving this, you will get this value. Similarly, now you will do for 720 second. Yes, 720 second initial was 35, and this is the left one will be considered as this pressure. What PT total pressure is at that time 63. So instead of this time, we will keep this 720 log 35, 2 into 35 minus 63, and solving, you will get this. See how you can say that it is a first order reaction. First of all, you should know that yes, this reaction is for first order reaction, and in general जो भी questions आपसे पूछे जाएंगे, everything will be first order reaction only, because second order third order के लिए आपसे questions नहीं पूछे जाएंगे इस तरह की. There is the integrated rate law is quite complex for that, so it won't be asked. Okay, now how can you justify it is first order reaction? If there are 2-3 time interval, we have to find the K value, and if the K value comes almost equal or equal, then we can say that yes, it is first order reaction. Got it? Either almost equal hona chahiye ya equal ho. So you can see that it is 2.1 and it is 2.2, almost equal. Yes. So that's why you can say that it is a first order reaction. But you have to find the, in this case, part is missing over here. So that it is question that average, what will be the average rate of reaction? This part is there. Find the average rate of reaction. Okay, average rate of reaction. This is the question. Average rate of reaction you have to find. So for that, what you will do? You will just take the mean of both the rate constant. Yes, that you have to find. So just take the mean. I have taken common because in both the case 10 to the minus 3 is common, so I have taken out, and just take the mean and you will get this average rate. It is almost equal hoga, which we got, isn't it? So this was the question. I hope it is clear. If there is any doubt, you can ask. Okay, now then let's move to next question. The next question is, the rate of a first order reaction is 0.04 mole per liter per second at 10 minutes and 0.03 mole per liter per second at 20 minutes after initiation. 10 मिनट के बाद it was 0.04 and 20 minutes के बाद it was 0.03 mole. So find the half life of reaction. How you will do? See, in this case, if it is the first order reaction, this is concentration is given 0.04 and at 10 minutes. Yes. And the another case is 0.03 at 20 after 20 minutes. So suppose that this is the first order reaction we have to assume, and it is already written over here. So reactant is going to convert into the product. Okay, so we will check that two different times concentration at two different times. Okay, so the first formula we can apply, this is K 2.303, and the time taken will be the final minus initial, log initial concentration upon the final concentration. Okay, so here but as the rate is equal to Ka, how can you say this thing, as it is the first order reaction? So can we say like this? Any problem in this? So write the two equation for this two concentration. Okay, so rate 1 will be equal to Ka1. Similarly, rate 2 will be equal to Ka2, isn't it? Yes, are you getting it? Now I'm just writing, this is R1 is equal to, you can write Ka1, and similarly you will write for R2, and this will be Ka2, isn't it? Now equation 1 upon equation 2, do it. Equation 1 upon equation 2, what you will get? You will get this thing. Yes, any problem in this? Now we have this formula, rate 1 upon rate 2. Here it is, instead of this A1 upon A2, can we write rate 1 upon rate 2? Tell me. Yes, so instead of this A1 upon A2, what I have done, rate 1 upon rate 2. So log K is equal to 2.303, the total time taken, log, so here log and then instead of this R1 value is given 0.04 mole per liter per second. Yes, so R1 value 0.04, R2 value it is given 0.03 mole per liter per second. So just put the value and solve it, you will get this answer. Got it? Now once you get the K value, you can find the T half very easily by using this formula 0.693 upon K. So put the this value and then calculate this. This is in the minute. You can leave in minute only. There is no issue because it is not written that to convert it into the seconds. But I have converted. There is no problem at all. Okay. So this was that question. And is it clear? You should understand this is rate of the reaction. Yes, at 10 minutes and rate of the reaction at 20 minutes. So we have to interchange this concentration with the rate. Got it? Now the next question. The next question is that the rate of a particular reaction doubles when temperature changes from 27 to 37 degrees Celsius. Calculate the energy of activation of such a reaction. Which formula it applicable here? Yes, of course, Helios equation, this expanded formula. Yes. So convert the temperature into the Kelvin. Don't forget to convert. If you will not convert, it will be wrong. Okay. So T1 is equal to 27 degrees Celsius. So converted, I got this 300 Kelvin. K1, suppose that it is K. T2 is equal to 37 degrees. So convert it into Kelvin, 310. And we know that every increase of 10 degree, the rate of reaction becomes double. So this K2 is 2K, whatever. Okay. Let me assume it. So now we have formula, log K2 upon K1 is equal to EA upon 2.303 R T2 minus T1 upon T1 into T2, isn't it? Just put the value. This is K2 upon K1. Can I write 2K upon K? This is 2K and this is K. And all this value I have kept. Yes, this will be cancelled. This is log 2. Log 2 value, we know that it is 0.3010. And then solve it and you will get this value. I hope there is no problem in this. Yes, this is joule per mole and you have to convert. If you want to convert it into kilojoule, you can convert it. Done with that? Any issue? Any problem? Okay, let's move to next question. The two reactions of a same order have equal pre-exponential factor. That means A value. Okay, but the activation energy differ by 24.9 kilojoule. Yani EA1 minus EA2 is 24.9 kilojoule per mole. Calculate the ratio between the rate constant of these reactions at 27 degrees Celsius. You have to find the K2 minus K1 if E2 minus EA1 is given 24.9 kilojoule. So Arrhenius equation, this is the formula and we have solved. Let it be in the pre-exponential factor, okay, because it is going to be like what? It is going to be cut, okay. So K1, this formula, K2, this formula, I kept it like that. AA will be cancelled and it will be EA like this, RT upon this. And it out. Now, what is this? This is, we can say that this is natural logarithm, okay. So can we write like this EA when this base are same? So can we write in like this? We know na, if it is x power m and up x power n. So what we write? We write x power m minus n. Can we write or not? This is equal to x power m minus n. So similarly, the thing I have done here. Yes, this will go up. So this minus this, yani ki this is going to be minus minus plus. So EA2 minus EA1 and RT will be come out in a denominator. RT will come out. Yes. Now put the value. This value is given EA2 minus EA1 is given 24.9. I have multiplied by 1000 to convert it into joule, kilojoule. Okay, because R value I'm going to put the joule per Kelvin per mole. So that's why this is multiplied by 1000. R value is 8.314. This is 8.314 multiplied by temperature is given 27. So convert it into Kelvin and this will be 300. Solve it. You will get E power and 9.983. So K1 upon K2 you got this. Yes. Now you have to find the ratio between this. But you can't live in this way. You have to find the log value. So ln, just take the natural logarithm दोनों side अगर हम लेंगे तो this will be ln k1 upon k2 and here it will go out. Yes, anti-log we can say. So this is done 9.983. Now ln will convert into log value. So obviously we know that if ln को convert करते हैं तो this will be this can be written as 2.303 log 303 log k1 upon k2. Can I write is equal to k1 upon k2 is equal to 9.983. So now what I have done, log k1 upon k2 is equal to 9.983 upon this 2.303. That is, and solve it. So now you got the log k1 upon k2 value. What you have to do next, take the anti-log. Anti-log if you do, k1 upon k2 is equal to anti-log 4.338. This will be, and the digit which is before the decimal will be converted into power, and you have to check the anti-log of 0.33, 4 of 0.33. Got it? 4 of 0.33. It will be like this. So this is the answer. Any problem in this? Yes. So this is the way how we will solve these questions. Now the next question. A given sample of milk turns over at room temperature 27 degrees Celsius in 5 hours. In a refrigerator at 3 degrees Celsius, it can be stored 10 minutes longer. 5 घंटे में वो खराब हो जाता है। अगर हम उसे 3 टेम्परेचर पे रखें, 3 डिग्री टेम्परेचर पे रखें, तो वी कैन स्टोर 10 टाइम्स लॉन्गर, 10 टाइम हम जो है वो ज़्यादा रख सकते हैं। You have to find the calculate the energy of activation of milk. So the same formula like our Helios equation, you have to use this expanded one. T1 is equal to 300 Kelvin. T2 will be, this is what? In the refrigerator at 3 degrees Celsius. So obviously that temperature will be, this is down. So 273 minus 3, it is 270 Kelvin. Yes, got it. And K2 is equal to, here it is, suppose it is K1. So according to K1 jo ho jayega, it will be, it can be stored 10 times longer. So obviously it will be 10 times longer. Higher the temperature, greater is the value of L. Okay. What does it mean? 1 second. So this is higher the temperature, we know that greater is the value of K. It's not L, it's K. Okay. So 300 degree temperature and this is 270. So at this the K1 will, the K rate constant will be higher. So that's why K1 is 10 times than K. Is it clear? K2. Got it? Now log K2 upon K1, use this formula. And you can write K2 instead of this K2, you can put the K value, and here 10K, so K cancel, it will be 1 upon 10, EA upon 2.303 R, 1 upon 300 minus 1 upon 270, temperature is mentioned here. So 1 by 10 is the value minus 1, you can write, because you can write it like this, 10 to the power minus 1 you can write, and we know that log m power n will be equal to n log m. So minus 1 will come from in front, and that's why it becomes minus 1. Yes, EA upon 2.303 R, and this is solve karo, you will get this value. So all this calculation you have to do. R value I have put it here, 8.314. Calculation, do this calculation and you will get this answer. Done? Any problem in this? Okay, so let's move to next question. Okay, so here is the instant of a reaction is 1.2 into 10 to the power minus 3 per second. So as it is per second, it is quite clear that which order of reaction it is. Think of it. And 2.1 into 10 to the power minus 3 per second at 40 degrees Celsius. Calculate the energy of activation of energy. Calculate the energy of activation of reaction. Yes. So the answer, how to solve. Here we are given K1 is equal to 1.2 into 10 to the minus 3 per second, and the temperature is 30 degrees. So I have converted it into the Kelvin. And similarly for K2 is given here, and T1 is given over here, 30 degree. Sorry, it should be 40 now. Here it is 40. It will be 40. So obviously it will be 313 Kelvin. Yes. Now substituting this value in the equation. If we'll solve this equation, K2 upon K1, here I have written, yes, K2 upon K1, EA 2.303 R, T2 minus T1 upon T2 into T1. So this formula, just put the value, log K2 ki value 2.1 into 10 to the minus 3 per second. K1 is given 1.2 into 10 to the minus 3 per second. Now, and is equal to EA, we have to find 2.303 into R is 8.3 joule per Kelvin per mole. T2 minus T1, 313 minus 303 into this. So now solve it. This will be cancelled, 3 minus 3 cancel, and you got this, isn't it? So now log 2.1 into upon 1.2, if you'll solve, you will get this, the value of log 2.1 minus log 1.2, solve it and do all this calculation, you will get that EA value is equal to 44126.3 joule per Kelvin per mole. And or if you want to find in the kilojoule, it will be like this. Yes. So this is the question. Now the next question, let's move to next question. The next question is, a hydrogenation is carried out at 500 Kelvin. If the same reaction is carried out in the presence of catalyst at the same rate, The temperature required is 400 Kelvin. Calculate the activation energy of the reaction if catalyst lowers the activation energy by 20 kilojoule per mole. So how to solve? Activation energy is going to be lowered by 20 kilojoule per mole. तो तुम्हें activation energy actually निकालनी है कि कितना था उस reaction का activation energy कितना था. ठीक है. So how to solve this? Suppose कर लो कि activation energy in absence of catalyst it was EA and in presence of catalyst it is EC. Okay. So there is the equation. This is the equation, Helios equation. I'm not going to expand it in form of log because here also it will be cancelled and we can find easily. So K is equal to A E minus exponential minus E upon 500 R. What is this 500 R? This is the RT. We know that temperature RT, E upon RT. So here it will be 500 R and T. Okay. Similarly for this it will be AE. This is RT. Second equation I have done for this. Okay. Since K is same in both cases, for a reaction, the rate constant is not going to change. Yes. Until or unless the temperature is change. Different अगर हम temperature अगर जब तक नहीं करते, the rate of reaction is not going to change. Okay. So what we have to see here, it is the hydrogenation of carried out at 500 Kelvin. If the same reaction is carried out in presence of the catalyst at the same rate, the temperature required is 400 Kelvin. So like this, okay, K is same in both cases. So that's why these two things will be equal. Okay. Now what next? This is equation 1 upon equation 2 you can do and solve it. So this will be, this is like same base are same, so we can make it power same. Yes. So EA upon 500 R is equal to EC upon 400 R. Yes. Now EC you got this 4 by 5 EA. Solve it. You will get like this. The question is given that lowers the activation energy by 20 kilojoule. So EA minus EC can be written as 20 kilojoule, isn't it? Now EA value, let it be EA because we have to calculate, and EC value, put the value of EC from this equation 4 by 5 EA. So I have put this and then solve it. You will get this EA value 100 kilojoule per mole. Done with that? Any problem? So this is the question. Now the next question. At 27 degrees Celsius, in the presence of catalyst, the activation energy of a reaction is lowered by 2 kilocalorie. Okay, activation energy is lowered by 2 kilocalorie in presence of catalyst. The same way we can do. Yes. Calculate by how much the rate of reaction will increase. How the rate of reaction will increase. So, in absence of catalyst, suppose the rate constant is K, and in presence of catalyst, we will find another way. So we can write in this way. This is the Helios equation. Yes, no issue in this. Now in the presence of catalyst, suppose that rate constant is Kc, or you can say K dash. Okay, in presence of K. So write the equation for the same. You will get this log K dash is equal to log A minus E upon 2.303 RT. You can write, isn't it? So now activation energy is lowered by 2. I have not written here. You can write the equation. This will be log K dash is equal to log A minus EA upon 2.303 RT. So here A will be same because for a reaction the pre-exponential factor remains constant. Yes. And since the question is given here that lowered by 2 kilocalorie. So activation energy is now EA minus 2. Yes. So this can be log K dash, as I told you. K dash is equal to log A, and instead of activation energy now it is lowered. So by what value it is? EA minus 2. So instead of this EA, I put this EA minus 2 upon 2.303 RT. Now this is the way. Okay. So you can bifurcate it. It will be log A minus EA upon 2.303 RT. And now this is minus plus 2 upon 2.303 RT, isn't it? So here, just take this, solve this equation, K upon K dash log this one equation 1, this is the equation 1, and this is the equation 2. You solve this two equation, you will get the, this is k dash upon k will be, you will get this antilog 1.4474, which is going to come by like 28. This is 10 to the power 1 ho jayega, and 0.44, 7 of 0.44 you have to check, it will be like this. Okay, 2.8 something aayega, multiplied by 10 to the power 1, it will be 28. So k dash is equal to, you got that 28, 28k. This is the way by which the rate of reaction will increase. So if rate constant is increasing by 28 times, obviously the rate of reaction will increase by 28 times. Got it? So this equation 1 and equation 2 divide karogi, you will get this. Okay, and antilog. So just try to do this calculation and tell me if there is you are facing any problem over there. Okay, so now the next question is the activation energy of a reaction is 94.14 kilojoule per mole, and the value of rate constant at 313 Kelvin is this. You have to find the frequency factor. So it's a log k is equal to log a minus EA upon 2.303 RT. That formula you have to use and you will get this. So EA is given, T is given like this, K is given like this. Now put the value in this equation. Yes, we know that log A minus EA upon 2.303 RT, we can write like this also. There is no problem at all. So now log A, if I have to find this log A, so let it be, this has to go in this side. So it will be log K plus 2 EA upon 2.303 RT. Now K value I have kept plus EA value, it is given here kilojoule, so we have to convert into joule because R value will be in joule. So that's why this kilojoule will also be converted into joule, and then 2.303 R value, and this is the T value. Put this value and you can get the log A value. After that, this is, after that you have to this solve karo, you will get like log A, this method. And this is the log A value. Okay, let me write over here. All this thing, whatever you are getting, this is the log A value. Okay, so for getting A, you have to take antilog. So antilog, it will be 10.965. That means the number which is before the decimal will come in the power. Yes, and you have to check 3 of 0.96 antilog and you will get this value. Okay, so this is the value of pre-exponential factor. So this was the question. I hope it is clear. Now the next question, and I hope it is the last question for that. So this type of questions we have done in the video also. I don't think there will be an issue. Let me just... Okay, so we know that this is the general equation where I don't know the order of the order with respect to A as well as order with respect to B. So what I have like assumed alpha and beta. At last, this alpha plus beta will give you the order of the reaction as a whole. Okay, so we can make the three equation with this help. All these three values, one value, this is the first value here. Okay, this is the second values here, and this is the third one here. So by using these three values, you just make the equation 1. This is equation 1. This is equation 2, and this is the equation 3. Yes. Now you have to check such a value, just say like there will be only one variable left. Yes, so if we do equation sorry, this is equation 2, it's not equation r naught 2, it will be. Okay, so if we do r naught 1 upon r naught 2, what it will be cancelled, this will be cancelled, and you can get the value of okay, sorry, I have done the mistake, just same it is. This is A value is 0.20 and here B is 0.10. This is 1. Okay, not 3. Yes. So here I have corrected. This is R naught 1 upon R naught 2 is equal to 1 because it is going to be cancelled out. एक दूसरे को cancel कर देगा. And here it is. This will also be cancelled, and this is 0.30 upon 0.10 power B. anything power 0 is equal to 1. So suppose that ये 3 है, this you can assume anything power 0 is 1, isn't it? So instead of this, can I write like this? This is 3 power 0. Yes, is equal to 3 power beta. So base are same, so power will be same. Beta is equal to 0. Similarly, next to what you have to do, equation, anyhow it is not going to same. So alpha, now beta value you know. So you can put the value of beta and find this. So just do this equation 3 upon equation 2 if I do. What it is, 7.16 upon 5.06, this 5 will be cancelled out, and then 0.40 upon 0.20 alpha, then 0.05 upon 0.10 beta. Yes, if you'll solve this, it is 1.412, and this will be 2 power alpha, and this will be 1 power 1 by 2 power beta, isn't it? Since beta is 0, so this whole part is 0. Yes, sorry, whole part is 1. So what you will get? You will get this 1.4212 is equal to 2 alpha. So there are the two ways. Once though you will find the log, or you can do the direct way also. How? Let me explain. Take the log both sides. It will be log 1.412 and this will be alpha log 2, isn't it? Log 2 value is 0.3010. So just the same thing I have done. This is log 1.412 value. You find it, you will get 0.1523. And this is log 2 value. You got 0.3010. So alpha will be like this. Dip this upon this. You'll solve. 0.5, that means the order of reaction with respect to A. Alpha is the power of A. Yes. So with respect to A, it will be 0.5, which you can say 1 by 2. And with respect to B, it is 0. Or another way, alternative way, you can say that this is the value of root 2, isn't it? And root 2 can be written as root power 1 by 2. Yes. So this is root 2 power 1 by 2, and this is 2 power alpha. So if the base are same, power will be same. So hence we can say alpha is equal to 1 by 2 or 0.5. Yes. So this was the question. I think all these questions are done, and you got the things. If there is still there is any doubt, you can ask. Till then, thank you, class.